In this video, we're going to talk about a practical diode. I'm going to solve an example based on a practical diode. So here is an example. Find the current flowing through a 10 kilo ohm resistor. 10 kilo ohm resistor is right here. And voltage V0 is right here in the following circuit by using constant voltage drop model. Constant voltage drop model or practical diode, both of them are same. Okay, so here there are basically three main steps. Step one, very simple one, find out the possible current flow directions. Okay, we know that current always flows from higher potential to lower potential. So the first thing we need to do, find out known potential points. So we know that the voltage at this point is positive 10 volt. Another voltage here I see negative 5 volt. Another voltage I see negative 3 volts. So I know those three voltage points. Now we know that current always flows from higher potential to lower potential. So find out possible current flow directions. So we know that current, it's a possible current can pass from 10 volts to minus 5 volts. Current can flow from positive 10 volts to minus 5 volts. That's one possibility. Another possibility is current can flow from 10 volt to minus 3 volt. That's another possibility. And another possibility is minus 3 volts to minus 5 volts, because minus 3 is higher potential than minus 5 volts. Okay, so if you look at diode D1, so here is my diode D1. So when we look at all the current flow directions, there are two possibilities. Both current flows are flowing from anode to cathode. Okay, and we know that diode allows current from anode to cathode. If this is the case, for sure this diode is acting like a closed switch. But here we are talking about it's a practical diode. A diode will have around 0.7 volts of voltage drop across the diode when it is in forward biased condition. The current diodes, the practical diodes which we see in the market nowadays, probably they can take around 0.3 volts, but I'm going to follow the textbook. In olden days it was like 0.7 volts, so I will take that as a 0.7 volt drop. Okay, so anode has the higher voltage and cathode has a lower voltage. So the voltage drop across this is 0.7. That's anode and cathode. Okay, now that's let me make this diode D1, D2 and D3. Now if you look at diode D2, same case, both currents are flowing in the same direction, so definitely that is going to act like a closed switch, but there is a with 0.7 volt voltage drop because we are taking that as a practical diode. And third diode D3 has two possibilities. One current is saying from cathode to anode, another current is saying anode to cathode. In this case, we don't know which direction the current is flowing. We don't know whether this diode is acting like a closed switch or open switch. Sorry. So diode D3, we don't know whether this is acting like closed or open because one current is flowing from anode to cathode. The possible current, another possible current is flowing from cathode to anode. So in step 2, what I'm going to do, I'm going to assume this diode is going to act like a closed switch, solve for it and find the parameters. Once you find the parameters, verify whether our assumption is right or wrong. If our assumption is wrong, then do it in the opposite way. So here I'm going to assume D3 is acting like an open switch. So here I'm assuming D3 is open switch. So D1 is going to act like a closed switch, but there is a 0.7 voltage drop. That's a D1. Same thing with the D2 and D3. I'm assuming open switch. Now the voltage at this point, it must be, we have 10 volts there, 0.7 volts drop there, so it must be 9.3 volt at that point. Okay, and find out any other voltages. If we know here V0 must be negative 3 volts because the current flowing through this 5 kilo ohm is 0 ampere. So there is no voltage drop here. So V0 must be negative 3 volt. Now the current must flow in this direction only. So you can apply KVL in that loop to find the current passing through that. I'm going to take that current as I. So if I start a voltage drop, that's going to be minus 10 plus 0.7 plus 10 kilo ohms times I plus 0.7 plus 2K times I minus 5 equal to 0. Why I took this as minus 10? Usually if I'm entering the negative terminal, I will take that as a negative. Entering the positive terminal, take that as a positive. So here this must be positive terminal and that must be negative terminal. So current is entering through the negative terminal. So that's the reason I took it as negative. Entering through the positive terminal, took it as positive. If it is resistor, that's positive. And here that is positive. And we're entering through positive, that is positive. And when it comes here, when we use a negative 5, that is negative terminal and positive terminal down there. So the terminal connected here is negative, so that is the reason that is negative 5. So here if we solve this, it is going to be 12K times I must be equal to minus 10 minus 5, 15. Well, 15 minus 1.4, which is 13.6 volt. So our current must be 13.6 volt divided by 12K. That current equal to 1.13 milliampere. So the current passing through this is 1.13 milliampere. So the question he asked for find V0 and current passing through 10 kilo ohm. So the current passing through 10 kilo ohm must be I. We found both. Now we need to verify whether our assumption is right or wrong. So I'm going to say step 3 here. So our assumption based on our what is our assumption? We are assuming this diode is open. We know that when that diode is going to be open, when the anode voltage is less than the cathode voltage. I know the cathode voltage here is minus 3 volt. Now what is the voltage at this point? Can we find the voltage there? So to find the voltage there, I know the current passing through this. I know the voltage there. Let me take this as Vx. So 9.3 minus Vx equal to 10 kilo ohms times 1.13 milliampere. So when I find Vx value, I end up with Vx equal to negative 2 volts. The voltage at this point is minus 2 volt. Okay, so the voltage here is negative 2 volt. So my anode voltage is minus 2 volts, cathode voltage is minus 3 volts, and you're saying this diode is acting like open switch. Is that true or false? Here it must be false because anode voltage is higher than the cathode. Okay, so it's a false statement. Okay, so since anode voltage is higher than the cathode voltage, this diode must act like a closed switch with a 0.7 voltage drop. So our assumption is wrong completely. So what we need to do, we need to repeat step 2. This time I'm going to make this diode is acting like a closed switch. So here we are repeating step 2 again. So here we have 2 different paths or 3 different paths. One path is coming in, other 2 paths might be going out. I'm assuming current is coming down because higher potential is right there, 10 volts. So I'm going to take this as I1 and I2 current is going out, I3 current is going out here. So I can say I1 equal to I2 plus I3. So I'm going to take the voltage at that point is Vx. At Vx apply KCL. Okay. In the previous case, applied KVL. How do you know which one to apply? It comes with the practice. So if you practice few examples, you know which one works better. You might be able to solve this by using KCL. by using KVL, but I felt like KCL might be easiest way. So I'm going to solve this by using KCL. So I1 equal to I2 plus I3. The voltage at this point must be 9.3 volt. So I1 equal to 9.3 minus Vx over 10K. How did I get that 9.3? 10 volts minus 0.7, that will give you 9.3 volts. Now my I2 must be whatever the voltage here, that must be Vx minus 0.7 minus of minus 5 divided by 2K plus I3 equal to Vx minus 0.7 minus of minus 3 over 5K. That will give me my Vx. Okay, why did I put Vx minus 0.7? Because the voltage, the V0 here must be Vx minus 0.7. Okay, so V0 minus of minus 3 over 5K will give me I3. That's how I end up with this equation. So here there is only one unknown, that unknown is Vx. So find Vx. So after solving this equation, I found Vx equal to minus 2.1 volt. Okay, so once I have Vx minus V0 equal to 0.7 volt. So Vx must be 0.7 plus V0, or I need V0 in this case, so I would say V0 equal to Vx minus 0.7. Vx is minus 2.1 minus 0.7, so the voltage at that point is minus 2.8 volt. Still, we need to verify whether our assumption is right or wrong. How do you verify that? So to verify diode D3, we're assuming this is acting like a closed switch with 0.7 volts drop. So here I have negative 2.1 volt. Here I have negative 2.8 volt. So definitely current has to flow from anode to cathode. Okay, so our assumption is right. To simplify it, or to verify it properly, it's a good idea to find I3 value. My I3 must be V0 minus of negative 3 divided by 5 kilo ohm. Okay, so that is going to be V0, I have negative 2.8 plus 3 divided by 5K, which is 0.2 divided by 5 kilo ohm. That will give me 0.04 milliampere. So there is some current passing through this diode. That current is passing from anode to cathode. So our assumption is right. That's how we verify our calculations. So I'll stop this video here. In the next video, I will explain more about we'll solve more examples based on this concept. Thank you.